Let's get started with the Git, one of the most common and most famous version control systems. If you didn't know about it, it is the right time to get introduced to Git. And one interesting tidbit about Git is it was written by the same person who wrote the Linux kernel. Linus Torvalds wrote the initial Git code, and it has been developed, and it has a lot of features that makes it so popular, and a lot of people use that internally. In fact, Windows has recently acknowledged that, I should say rather, Microsoft has recently acknowledged that Windows development code happens on Git only. And this is one of the biggest code bases in the world, that is Windows source code, that is also being stored and managed using Git software. And when I say that, it doesn't mean that it is publicly available or it is in the Git website, GitHub website. We will see the difference between GitHub, GitLab, and all those things. But it's interesting to note that they are also using Git. So that goes to show the power of Git, and that is available for all of us to use. So let's get going. So this is the brief agenda of what we are going to discuss today. What is version control, why we have to choose Git, and how to install and configure Git, and quick examples. So we'll try to run through some of them as fast as possible in the interest of time. So let us start with version control. What is version control? Why do I need a version control? Why can't I have it happily in my home directory and then try to share it? Why should I put it in somewhere where somebody else has to manage it? So these are the questions that we need to ask before going and jumping into version control. If anybody is a developer or a scripter, or anybody has done any kind of development, or even Word document, if you're writing and then you want to edit it after a few days and then find that some mistake has creeped in, you want to roll back to the previous version, then you are thinking like, God, is there not a other way to solve this problem? So that is the problem that we are talking about. Let us go ahead and see what other problems are there. So let us say you want to write some code with a group of people. Probably you might be writing it all alone. Probably you might be writing with a group of people. So basically, people don't write a development code all alone unless you're a super genius. You work with a group of people, you work with a team, and if you will be lucky if the group of people are sitting next to you. And quite often the case is the people are not sitting next to you. So how do you share a code, or how do you develop something when a lot of people are involved? How do you merge all those things? So that is the problem that usually we have. So let us take a very basic example. You want to write some code with a group of people. So what you do is you do something like, let us say you want to find the commented codes within files, or you send an email to our peers, or you use Telegram to send the files. You need to share it, right? You need to copy. I mean, all of them has to develop a particular functionality, and each person is doing some different pieces. Say, for example, one person is doing the login, one person is doing the payments, one person is doing the inventory management. But all of these things has to go together so that they can all work very well. So you need to share it, and then you need to cancel it if the code is rejected saying there is a bug, or some in cases who somebody wants to know what was the version of the yesterday's files. If you're emailing it, how do you go and track it? Do you go and dig back your emails? All these things are not going to work when your project size is really big. Probably if you're having 1 or 2 page applications, this will work. Probably if your code is like 100 lines, this might work. But let us say if your code is having 10 files and each guy is having the responsibility in a particular segment in each of those files, and you need to somehow find a way to work together and get it working. So these are all the problems that you have when you are trying to transfer the files and manage it within your own home computers or laptops or directories. So how do I solve that? So one of the easiest way to solve is to have a version control system. You might put a desktop server in your office and then try to install some kind of version control system and then start using it. So typically what exactly a version control system provides you is a system that keeps records of all your changes, and it allows for collaborative development. And finally, and most important, is it allows you to find out who made the changes and what the changes were and when they made those changes. So when you know all these three parameters, who, what, and when, it allows you to roll back easily. And interestingly, it can allow you to blame the person who did it as well. In technical terms, it is not exactly blame, is fault finding or finger pointing. You ask the developer saying, this code is having a defect. Can you please go and look at the defect and fix it as soon as possible? So interestingly, Git also uses the word blame, but in a more professional sense, it is not exactly finger pointing or trying to demean somebody. We are trying to help each other to find defects before customer finds it and causes some problems. So these are some of the features a version control system provides us. So let us expand the scenario now. So you wanted to write some code and then you have a local version control system, and the version control system provides something like this. You have your version database and all the different versions are stored here as version 1, version 2, and version 3. So when somebody wants to check out a file, they will be redirected to the latest copy automatically. The version control database will take ownership of that request, and they will be sent a request for version 3. If you want particularly version 2, yes, that is also possible. Remember, we have seen something like this in S3. You can enable versioning in S3 and you can roll back to an older version if you want it. So it is very simple, but in this case, we are using a local computer for that. But when you have a local computer, how do you have a global group of people work with it? Because this time zone is different, that time zone is different, and still there will be a lot of changes happening. And will your local computer will be able to manage with all those changes? So that is the question that we need to ask when you're having a global team. So let us see what other options are there. So again, now you're writing some code with people in your team. So you need to have a little bit of a centralized version control instead of having it in your local desktop alone. So far we were writing it with our own desktop. Now we are trying to write it with a bigger team which are distributed little bit. So what in this case happens is you will have a centralized version control system. That is, a main server will be there and each collaborator will have a copy of the code, and each collaborator will be trying to make some changes, and all those changes will be pushed to the central server, and the central server manages all your code. So this kind of deployments were also possible a few years ago. These were working. Let us say your headquarters is in Seattle, and all the developers all across the world will be committing your code to Seattle server. And think of the load that might be happening on the Seattle server when all over the world people are trying to commit to it. Then you need to manage the high availability and fault tolerance and all those things. So you introduce a single point of failure, or you're trying to replicate it in your master server itself. So you don't have a system where it is easy to scale, at the same time it is easy to use also. So you have to find a trade-off between a faster way to commit the code and a better way for developers to manage the code also. So the operations part of it and the dev part of it has started troubling each other already now when we are trying to do a centralized version control system. This is again, by the way, a small team which is all in your company now, little bit distributed. But what happens when you want to write some code with a truly distributed team? Think of it like an open source code that we see in the world. You don't even know at what time somebody is going to come to office and commit some code. That person might be writing some piece of code over the weekend and he wants to do a bulk load or bulk commit. Or that person might not even come next week and then or next month, or even might not come ever at all. That is how the open source world works. So how do you design a system to manage for this kind of distributed teams where the code is coming from people? It might not come from people, but it still should be able to validate all the code and manage the versions. So that is when you do something called a distributed version control system. So the difference here is now each collaborator will have a local server copy, and when I say server copy, each collaborator will have an entire database copy. That is not only the files that he or she is responsible, they will have a copy of the entire database or entire code repository, and each of them will be modifying only the copied segments. That is, they will be modifying only a small segment of the files. So, and then these copies will indirectly send it to another master, which will be a cloud master. Most probably this is stored in the cloud. And this way you have multiple fault tolerance. Say, for example, this one is completely gone. Let me just do that again. Let us say this collaborator is completely gone and unavailable for a lot of times. but you still have two collaborators sending data, and the master repository will have the latest data. So likewise, when the entire database is globally distributed, and every single collaborator will have a copy of the data, and you can roll back to the latest version from the copy of a last developer that is available and having the code. Even if all the other people are offline or not committing or having the code, the last developer or last collaborator that is available, he will be able to deploy the code and roll back the code or make changes to the code. This is how a distributed version control system works, and there are many tools available for doing a distributed version control system in the market. So let us talk about some of the popular version control tools that is in the market right now. My animation should start anytime. I'm waiting. No. Okay. So my animation did not start, but anyway, these are the popular version control systems that is available in the market. So Git is one of the most famous tools available, and Bitbucket by a group called Atlassian. Atlassian is an Australian-based company, very famous in the CI/CD world. Bitbucket is their product, which is similar to Git, but a lot of different features for cooperative team development, collaborative development, and all those things. Subversion is the oldest sturdy tool that is in the market. You can say that is being used for ages. It does not have some of the cool features or jazzy GUI like Git or Bitbucket, but it does the job. Mercurial, Perforce, or all the other tools. In fact, Google has publicly acknowledged that they are using Perforce for some of the teams or some of the actual work. So it is interesting to see some of these big companies and trying to share the tools that they are using. So ordinary developers or smaller companies can take their lead and try to test out which tool is suitable for them and use it. So again, one size doesn't fit all. You will have to choose the ones that you are familiar with or you are going to be comfortable with. Or if you want to go with the mass market, Git would be a very good choice in that case. I'm just going to show you why that is good in the next few slides. So now we spoke about version control system. We are going to see why we need to choose Git when all the other flavors are there. So let us look at some of the benefits of Git. Most important thing is I really appreciate Git being an open source system, meaning you can go and look at the code, the source code binaries, libraries, dependencies, everything of Git. It is absolutely available. You can go ahead and modify it, create your own version on top of it, and release it into a better product. The community will get benefited. So this is a distributed version control system, not a local copy, not a centralized copy, but it is globally distributed. Everybody gets a copy of the code. So it is truly fault tolerant in that way. Nowhere, nobody holds a complete authority. It is distributed, so you can merge and commit or pull or make all those changes in a truly collaborative manner. And the interesting part is it is designed for speed and efficiency. What in other words it means is it might not have the greatest of graphs or flow that you might imagine with Atlassian's Bitbucket or some other tools, because this tool is mainly designed for running it in CLI mode, that is command line mode. Almost all the features are built first for CLI mode, and some of the features are supported in the GUI mode. For a beginner or learner, a GUI is very good and efficient, but if you want to do some really complex things, going to a CLI is really fast, and you can do a lot of things that cannot be possible in your GUI. So this tool is built for speed, not for ease of use, or rather for eye candy issues. So that is one reason that we should use Git. So what do I mean by fully distributed? We spoke about it some time back, but let us look at it a little bit in detail now. When I say fully distributed, what I mean is everything, almost everything is local. All the copies, the commits, the hashes, everything is local, which means that everything is going to be fast because you are interacting with files that is in your computer. You're not dependent on your internet connection. You're not dependent on your corporate firewalls allowing you to commit. You're not dependent on some other party allowing you to commit. You are interacting with your local machine, and only when everything is ready, and if you're going to release your feature to the public, then you're going to push your latest code to the world. So at that point only you are going to send your copy of the code to the centralized repository. Until then, everything resides locally. So it's amazingly fast. And as I said, you don't need an internet. It works offline as well. And basically every clone or every code clone that you have is a backup. So you can roll back if something goes wrong centrally. Working offline, no network needed, meaning you can do committing of the changes or merging branches, switching, performing a difference, viewing the file history or versions, everything. You don't need a network to do any of these activities at all. Think of when you're talking about the cloud, everything is dependent on the network. You need to have a network connectivity to even see whether S3 is online or offline. Whether you are using code commit for doing all operations, you need to be connected to Amazon account to do your code commit, all those things. But when you're working with a Git, you can possibly work offline completely and then push your repository once it is ready, or push your features. Let us start calling it as features, because when you're developing, you're going to be releasing features or improvements or defect fixes into the code. So when your feature is ready, you will push them to the cloud. And this is another interesting reason I would say I would go with the Git, because you can see the blue color graph that is like growing phenomenally when compared to the other 3 or 4 products. The Bitbucket is a red color, Mercurial is number what is the Mercurial color? It is yellow, yeah, and Subversion is green, Perforce is purple. So you can see that GitHub is like way rocking. This chart was made in 10th of June 2017, and I'm sure that this number is not going to drastically change the last 1.5 months. Pretty much it will be remaining the same for some more time. So if you're going to propose Git for your company or your client, I don't think so they will be firing you for that decision. So who else is using Git? This is another interesting one. Let us see if it works. These are all some of the companies that are using Git, and some of the big names are there: Google, Facebook, Microsoft, Cisco, and there are a lot more are there. I couldn't put everything. I couldn't find the logos of all the teams that are using Git, so I just picked up some of them which are really meaningful or make an impact to the reader. So as I said, big teams are using it. So for a small company or anybody wanting to learn Git, that should not be a problem at all. But how do I learn it? Let us remember that Git is just a tool. So we should be able to easily understand what the tool does, what are the features of the tool, and gain some mastery over that tool. So there are 3 different flavors of Git is there. One is Git, GitHub, and GitLab. Let us try to see if we can find the differences between all of them quickly. So Git is for command line, and when somebody says it is for GitHub, then it is a web interface. That is the simplest difference that you can find for. So if you have a Linux or a Windows laptop, and if you want to install Git, you can go ahead and install it. If in Linux, it is as simple as install Git in Red Hat or CentOS or Fedora. If you are in a Windows, you need to install the Windows GUI package. That is, Git GUI will be there, and you will be provided with a GUI for the Git command line options. So basically, it also installs Git command line, and then there is a wrapper which you need to install for GUI mode. And even in Windows also, you can purely use the command line. It comes with a built-in SSH shell, and you can launch that SSH shell and then interact with the Git files and commit the Git files to a centralized repository. So when I'm talking about GitHub, it is a github.com website. You can go and navigate to your account. It is publicly available. That is one of the key differences. When I say Git, it is local. And when you say you are going to use GitHub, that means that you are going to use the public repository of a GitHub version. So this is just the thing that I was saying. So GitHub is also a code hosting site free for public repositories. So if you want a private version, that is, if you don't want to share the code with the public, then what you need to do is, of course, open your purse and then pay some money, and then they will give you the code, and you can install it in your private repository or private server, and they will provide you support for that. Exactly. If you are catching the point, why would I want to pay money to an open source product? That would be a very interesting question. If it has not come to your mind, you should think about it. Why should I pay money for something which is open source, which I can freely download? So if you didn't get an answer, ping me. I'll let you know later. So that is GitHub. Let us see what is GitHub looks like. So this is how GitHub looks like. If you go to github.com, you can go ahead and register for it, and you can create your own account. It is absolutely free for public repositories. That means that anything that you want to store in github.com will be automatically available to the entire world, and they can copy your code or modify your code and improve your code also in some cases. So I would strongly recommend you guys to go ahead and register yourself for a GitHub account, and then start committing some code here. I'm sure when you're interacting with AWS, you will be definitely writing some scripts or at least some command line options. So it is a good place to store scripts and files. There is something called gist is also there, GIST is also there, but I will leave that for you guys to find out what it is. People use GitHub for all kinds of things, not just version control. You can have a version control for a development environment, even for scripts, even for static images also, so that you know that the inventory for a particular product has changed when somebody is trying to upload a new image for a t-shirt or a pant or a belt buckle, think of things like that. So you know that everything has to be version controlled, so you can clearly control what is happening in your site or a portal. So finally, the third option, GitLab. GitLab is the open source version of GitHub that enterprises can run on their own servers. So if you pay money, GitLab is what you get, and they will allow you to run GitLab on their own on your own servers. So the source code and everything resides within your premises, and unless you allow access to some third parties, nobody can access it. So if I have to make a guess, out of GitHub and GitLab, Microsoft will be using GitLab. So you have to correlate it in that way where GitLab will be used. And if you and me are going to learn something and want to do some cool stuff, then most probably we'll be using GitHub and Git itself. Whereas enterprises will most probably will go for GitLab. Moving forward, so this is how a GitLab site looks like. If you want, this is the URL. You can just go and say gitlab.com also, and then you can use the sign in, sign up option. Once again, here also a free version is available, but you don't get any kind of support or anything. You can host your code here as well, but that also has some deficiencies that because most of the people use GitHub for doing public repositories, and whenever you are talking about the GitLab, it is mostly for enterprises because of the additional features. Some of those things that comes with GitLab is designed for them. So this is how it looks like. Go ahead and sign up here as well if you want to. So we are going to talk about a little bit of a Git installation and Git configuration now. I'm just thinking how best we can proceed here. So we will see how to install Git and how to configure it so that it is personalized for you and it looks and feels the way that you want it to feel it. So first step is installing Git. It is, in my opinion, is one of the most simplest and straightforward of things that you can do. It is as simple as running a one-line command. And from here onwards, there is a basic expectation going forward. That is, everybody who is listening to this or who is watching this is expected to be familiar with running some commands. Either it can be in a terminal in Linux or a Mac or command prompt or PowerShell in Windows. So whichever is the most convenient, choose that. But we are going to run everything in commands. There is no point and click from here onwards for some more time. So it is very, very trivial. As I said, you can go, if you're in a Linux instance, say for example, Red Hat, CentOS or Fedora, all you have to do is type in m-y install git. That's it. It automatically goes ahead and installs the package and dependencies and everything. Of course, with you can do the same thing with Ubuntu or SUSE Linux or other flavors of Linux. And there are packages for Mac as well. There are packages for Windows as well. You can go ahead and download it and install it. There is not much complexity or dependency like you have to have 10 steps to do installation of Git. There's only one simple command line, and it works flawlessly most of the times. I have done both Linux, I have done both Windows, and I can guarantee tell you that both of them, this as well as this, works flawlessly every time. When you just download the package, double click on the installation exe, it works in Windows, and install Git, it works blazingly fast. You can't even move away from your desk by the time it will be completed. So go ahead and do that. Customizing your environment is the next step that you need to do when you're talking about a Git. There are two important items that you almost mandatory, I can say, so that your Git is having your username. That is the first thing that you need to set up. And next thing is your user email, because we are talking about a globally distributed version control system. So when you're having a globally distributed version control system, you need to be uniquely identify who is the user that has changed the code and how to contact that user when something goes wrong. So these are the two pieces of information that helps to do that. One is your username and next is your email address. You can have any username. It is not necessary that you have to have your officially validated username, but your user email has to be something which is legitimate, meaning it just should not be randomly imagined junk mailbox which does not exist. Because if you are going to start writing some code and trying to commit it to a very popular repository, and in case there is a defect with what you have created, they are most probably going to remove you from the they are most probably going to remove you the permissions to commit to that code again. It is definitely possible. The admin for that repository can definitely block your email address from making any further commits. So that is the reason you need to have a username and an email address for your repository. And once you set it up, it is config-list lists you the other configuration options you have, but these are the two important or mandatory things that you need to configure in Git. The rest of them are you to customize your environment further. You might set it up saying how often you want to commit. Do you want to commit it automatically when, or do you want to send the code to your centralized server as soon as you make a commit? When I say commit, let us say you're writing a simple file. There are 10 steps to commit that 10 steps to complete that feature. And let us say that you have written 1, 2, 3 steps and the remaining 7 are pending, but you don't want to lose this 3 steps. So you would want to save that 3 steps. So this action of saving it is called commit. We will see what is the difference between this commit and then pull, merge, all these things later, but basically just think of it as saving the file to a centralized system, local system, not centralized system. So now your 3 steps are here and you still have 7 more steps to go. So do you send these 3 steps to your centralized system or keep them locally? That is a decision that is left to you. You can configure your Git to make that decision. Whenever you are completing each step, you can send it, or you can finish it all the 10 and then send it. So that flexibility is absolutely to you, and you can automate it in different ways. Finally, Git help is one fantastic command. It almost has help on all the commands and options. If very verbose output is there, you can read through it and help yourself whenever you are stuck. I found it very helpful when I was trying to do some things in Git, because it has very powerful commands, and sometimes we cannot remember all the options and what are each of the flags and options are available. So in that case, Git help is very useful. So what are the operations that I can perform in Git? So I spoke about committing. So what are the other operations are there? Committing is just one operation. So let us look at those things now. So the most basic of operations, creating a repository. So that is the starting point for your repository. And next is making changes to your repository. So of course, you create a repository is basically for creating a product or a feature. Then the next step is to make some changes. Probably you would have completed writing the code, then you would have written the code and then want to publish it. So you're making some changes when you're going to publish it. So once you make it published, then you want it to be parallelly developed. That means you want other people also to contribute to your code to make it look better and improve it constantly. So we are talking about parallel development. So that is another operation Git allows you to do. And finally, you want to sync repositories. That means that another person is also having a repository of having similar features. So they want to sync your code and then they want to try and modify it or try and merge it with your code, or they want to sync some features to you. So that is also possible by using the operations called syncing. So what are the commands that I will do? I will use for these operations. That is what we are going to look at. Remember, I said in the beginning, almost everything is command line here. Almost everything. You can do some of these operations through GUI, but 9 out of 10 times a command line goes in front of GUI in the Git world. So we are going to look at the commands now. Let us look at creating the repositories first. What are the commands that are available to me? Git init. It's a very simple command. When you say git init in a particular directory, Git ensures that everything under that version, everything under that directory is version control. It creates an hash map. When I say hash map, it creates an encrypted it is an encrypted SHA encrypted hash of about 16 or something like characters. I can show you a number of characters. You can count it. For each and every file which is inside your directory, map is created, and whenever any changes, it creates another hash and tries to compare these two hashes, the previous one and the current one. And if there is a change, it will say that there is a change here. Do you want to commit it or do you want to ignore it? So that is how Git keeps track of all the changes that is happening in your repository. So that git init is the command for creating your repository. Now what other commands are there? Let us look at it. So while making changes, you have three different commands. So git status, as any other Linux command will do, it gives you the status of the repository, or whether it is in sync, whether everything is up to date, or everything is in order, or is there an error, is there a problem with the repository. Those kind of messages you can get from git status. And git add is when, let us say, you initialized your repository and there were 10 files. Now all your 10 files are version controlled, and suddenly you decide that you want to create a new file which was not included initially. So that is when you use git add to add the 11th file into your repository. So git add is as simple as that. And finally, we spoke a lot about git commit. Saving your changes to your local repository is git commit command. For parallel development, what are the commands I have? You have git branching, meaning you outsource the job of developing a particular feature to another developer. Then what that developer does is he copies the code and creates another branch. As the image that you see here is, let us say this is the main branch where all the important development happens. And you call a developer and say, you go ahead and start a new feature. I want it to be really secret. I don't want anybody to know. I don't want any of the code about the new feature in the main line. This line is called the main line, where the production deployment happens, whereas your dev test, everything happens in a branch. So you call your developer and say that I want the super secret feature to be developed and I want you to create another branch for that. So what he does is he goes and issues a git branch command, and automatically everything that is here is copied to another repository, or another copy is created, and that developer will be working on it parallelly. And once everything is ready, he will then do a merge here. So you see here, first we do a branching, and once everything is done, you do a merging. So finally it reaches the main line and it is ready for production deployments. And sometimes you find that there are a lot of multiple branches are available and you want to merge them. So it is not easy to merge a lot of branches at the same time. So git rebase is one of the commands that will help you to merge in other words, do a complicated merge for parallel development. So this is really advanced. When you do git merging itself is advanced. So git rebase is little bit taking it to the next level, you can say. And the way that git merge and rebase works on the background is what the difference is. Moving forward, what are my command options for syncing the repositories? You get three options. When I say syncing, we are going to push the code to a distributed version control system. So far, we are all in local. Now we need to send it to the cloud or in a distributed way. So when you do this command git add origin, you are nothing but adding an URL to your repository where all your code will be sent. It might be an URL for your company's Git server. It might be a GitHub repositories URL. It could be anything. And now that you are want to, let us say you have shared your code and you are done with that, and you want to start looking at other people's code that is being developed in the internet, and you want to have a look at them, then what you do is you do something called git pull. In other words, git pull is here. It pulls the code from the remote repository and creates a local copy for you, and then you will be able to have a look at the code that is being stored there. And just as the word says git push, it from your local, you're sending it to the remote server now. These are the different commands. So if I counted, there are about 10 commands. If you are able to gain some amount of mastery over these commands, I would say you have learned Git, and you should be able to survive in the Git version control environment. You should not be left alone when people are talking about some features or doing this, that, then you should be able to clearly tell them, this is what happens in the Git world, these are the commands that is happening, and these commands are used for these operations. So that is how a quick summary for Git looks like. So as I was talking about vocabulary, because this is important when people are talking about Git, some of this vocabulary comes into the picture, or when I say version control system, some of this vocabulary is important. These are all the technology terms related to version control systems. So let us look at that. Branching, commit, we saw already these two. Indicator of a divergence from base, or another feature release, or might be a defect fix. It could be anything. A branching can be for many number of reasons. Parallel development, defect fix development, or isolation of a particular feature. It could be anything. So for example, when I say isolation of a feature, let us say your company is having a product, and that product has 2 to 3 different features, and suddenly you find that feature number 4 is more popular than rest of all the 3 features combined together. So what you can do is you can spin off that particular feature alone into another separate product, and completely you can create another Git repository for that. So it quite often happens like that in the real world. So if I have to quickly think about example, so Google Maps was an interesting example there. So let's go back to Git commit. You heard about that quite often. So forking is nothing but creating another copy of the repository. Say for example, when Oracle bought Sun Microsystems, the MySQL developers did not exactly like it, and they went ahead and created MariaDB, and Oracle has the patent for MySQL still. So there are 2 versions of MySQL available in the market. One is MariaDB, which is created by the original developers of MySQL. So this is what happens when they fork the project, which means that they copied the original source code and created another version of it, and then they started developing it. This happened not only for MySQL, it happened for OpenOffice as well. There's 2 versions now, Apache OpenOffice, and then the one that Oracle owns. So like this, the industry is replete with a lot of examples for each of the features that you can see here, whether it is branching, commit, or fork, or organizations, or issues, everything. When I say organizations, you can create GitHub repositories for your finance department, for your HR department, or you can organize it based on features, whether it is login credentials, SSO, or it is payment systems or inventory systems, or it might be database people, it might be operations people also. Even chef recipes, Ansible playbooks also get stored in Git or some kind of version control system. Pull request, as the explanation says, it compares the edits and see if the team wants to accept the changes. So when you send a pull request to another team, you are literally asking them to see, do you like my changes? Do you want my features? Do you want to pull my features into your product if you like it? So the team gets a request and they review it and accept it if they want to. Think of it like a gatekeeper system. Finally, the word is repository. This is beaten around so much, so you should be already knowing that. So let's move forward. Quick examples. So this is where we get our hands dirty and try to learn what all you can do with the Git, and what are the different commands that we learned can be used in which scenarios. So let's go ahead and see there, Git internals. This is how an anatomy of a Git looks like. Inside each working directory, inside any repository, there is a working directory, and then there is another section called or logical segments. These are not physical items, these are all logical items. It is called index or staging. It can exist in two states. There is an index and there is a staging state, and then there is finally the final repository itself. So in your working directory, you will have all these logical structures. Git maintains these logical structures in its own way. I mean, there is a directory structure inside a git directory will be there. We will see that as well. But all these things are for Git to manage itself. We don't have to do anything here. But sometimes when your merging goes really wrong, think of you're trying to merge from 100 different developers from all around the world. There is obviously some feature is going to overwrite some other features, and something might go wrong if you're not being careful. So you want to go to this internal directories and find out what is the oldest commit, what was the hash during that time, what is the new commit, then try to find out how you can roll back properly and up to which commit you want to roll back. Because when you are talking about 100 developers, each of the developer would have made some 10-20 commits to their code. So we are talking about 1,000 commits, and we are trying to merge 1,000 different changes in a single file. Saving. When I say commit, we are saving the file. Let us say a file has 10 lines, and you write the first 10 or 5 lines and save the file. So that is called as a commit. So now you are going to write 6 lines. That is a commit, and you're going to finish 10th line. So Git will know that how many times you have saved it to the index. So that is how Git knows that something has changed and something has not changed. So as I was saying, your working directory is a copy of your project, whereas your repository is your object database. Git treats everything as an object. It can, when I say object, just think of it like S3 only. The object can be an image file, it can be a text file, it can be a script, it can be a movie item or a MPEG or MP4. It can be any object inside the working directory. So we will look at staging in little bit while. So files can be in one of two states in the staging. That is, one is tracked or untracked. So when I say tracked, the files that were in the last snapshot, yeah, Git can store media files too, because you want to version control images. As I said, let us say you are an e-commerce website and you have a brand new tops for say summer, and then suddenly the seller changes the images which was originally there, and then people who ordered the product uh, based on looking at that image are asking for a refund because the seller has changed the image and they are confused that they are going to receive the same product or not. So you need to have control over the images as well. Yeah, good. So files can be in multiple states or two states. It's like quantum state, you can call it, tracked or untracked, not at the same time though. When you say uh, tracked files are those that were in the last snapshot, meaning when Git took inventory of the directory, those files were not there. So they were either unmodified or in modified state, or they are in stage state. When I say stage, they are about to be committed to the repository. They are waiting to be committed, meaning you are working on that file and you have still not saved it, or you have not informed Git to add it to its repository. When I say untracked, these are files completely ignored in your repository or in your directory. Say, for example, you have a configuration file where you have stored your passwords, which your scripts will read during runtime. And this configuration file, because of its sensitive nature, you don't want to commit it to the version control repository. You always want to keep it outside it because of the sensitive nature. So you can have something called a git ignore. It is an exclude list. Whatever files you put in the git ignore file will be excluded, and they will be called as untracked files. So when we say Git, there are two options, tracked and untracked, and within tracked itself, there can be three states, unmodified or modified or staged, and completely untracked files. So finally, how do I get a Git repository? Let us say you have installed it and configured it and you learned all the commands. Now, how do I get handle on Git itself? So there is a very simple option. How do you create a repository? Use the git init command. Remember, we saw the create repository option. So git init is your command for creating a repository. So what you need to do is go to an existing directory or create an existing new directory, mkdir, or create a new file, say touch hello world.py. Then you go to the directory and say git init, and git will initialize in the current directory, meaning it will create an index or its own hash map database, and it will try to find out what are all the files which are already there in the directory and create a map for everything. And from that point onwards, git will track everything. So when you once you do a git init and then do a tree-a command for the objects, it will show you its internal structure, and it should look something similar to this. It is not necessary for us to know this structure, but when you are in really deep shit, understanding the structure helps. So as I said, if you want to add something else in the repository, or if you want to add the whole directory itself to Git, or if you want to add a particular item, git add command is what that is going to help you. So this is going to be the entire tree structure when you have a Git objects, if you have a lot of objects. So remember the hash map I told you, this is how each file is going to be tracked. It will have an alphanumeric key, and it is a zlib compressed SHA-1 algorithm key. And every time when there is a change, Git will compute this hash key, and then it will compare it with the previous version. So since there is a little bit of a computational process is involved, think of merging the commit of 10 different people. So it has to take each file, create a hash map, try to compare it with the previous one, and then find out whether yes, this has changed, this has not changed, let me move on to the next file. And for each file there can be multiple commits, and you multiply it by the number of files, that is an unimaginably complex number. So that is when your version control repository like Git really excels. It does this in a blazingly fast manner. It's really good. If you start using it, you will feel the power of it. So when you do a git commit for a first time, that is when you're trying to save everything to a version control repository, you will get an output, something similar like this. It will say that one file has been changed, and then I'm going to add that file to my repository. You see here, it clearly says one file changed, and there are 0 insertions or 0 deletions. Depending on, like here, there's a small comment. This is the comment that I'm going to give for my commit. The -m is the comment option, and I'm adding just a comment saying initial version. So there is, I think, one more command here. So after you do a commit, that is, you let us say that you have not changed the file, and you change the file a little bit and you committed, and you see here the hash map has changed from E6 has gone to the bottom. This is the E6 that I'm talking about, and you see here E6 has gone to the bottom, and there are 2 more commits that has happened on top of it. So that means that there are 2 more changes Git has identified that has happened on the same file. So this is how it keeps tracking of all the changes, and it knows the difference between these two, because that variable or that information is also stored in the hash map. It knows exactly which line you have changed and what are the changes in that particular line also. It will be able to do a diff or a difference and show you the difference if you look for that. So this is how the Git internals looks like for a repository. Let us move forward. Now we have created a repository, we have added a file, we have tried to add a commit, and then we saw how it looks like internally. So now we are going to clone a remote repository. We are going to pull down a repository which is already existing. So when you're cloning a repository, the command is very, very simple. I'm just giving an example of one of my repositories, and the command is to git clone and then the URL. It automatically goes and downloads the necessary files, and then it creates the necessary folder structure in locally, and then gives you the output. So see here, this is the directory structure that is here, and wait a second, yeah. So when it automatically the directory structure is created here, and automatically the directory structure is created when I do a git clone. That means that I have copied a remote repository locally, and then the directory structure is copied, and when I do ls-l or a tree-a, I should be able to see the contents which was remote. It has locally copied everything, and it shows me the entire list of the files that is inside my repository now. You can do a tree-a, it runs really very big. I've just shown you a small example of how a tree-a in a Git repository looks like. So if you go ahead and do that, your output might be different because the commits might have happened. This is a screenshot. So the commit might have happened sometime back, and there are more commits might have happened here. Here I've just shown you a small example of 3 commits. I've just removed some other commits for readability. So go ahead and look at it. So the highlighted versions are the different commits, just to highlight it and make it more visible and readable. Okay. So remember the git status command I showed you. When you pull down a remote repository and you run a git status command, it will show that there is nothing to commit. Working directory is clean because you have not done anything here. So it shows that everything is all in order. So you can keep proceeding and move on to the next phase of it. So let us talk about a simple workflow now. So the workflow looks like this. Now, the first thing is you have created a file. Then the next step is to edit the file. And once you edit the file, you need to stage the files. That means that you are going to tell Git that these are the files that I have edited, and I want you to review and commit those files into your database or into your hash map. So a basic workflow looks on these 3 parameters: editing, staging, reviewing, and committing. Quite often people ignore the reviewing part because they are the people who write the command or write the code, and they just think that they know what is they have written, and they skip the review part and go directly to the commit part. So let us look at the editing part of Git. So let us say you have a file and then you did a VI or Vim or Nano, whatever you like that, and then you do a Git status. Now you see that in Git status, it will show clearly saying this file has been modified. Remember earlier it was showing that your working directory is clean and nothing to commit or nothing changed. Now it shows that when you say a Git status command, modified, you are on the branch master, and the changes are, see here it also gives a very important thing: changes are not staged for commit. The 3 phases or 4 stages I showed you in the previous slide: editing, staging, reviewing, and then only committing. So it says that, or it gives you a nice little warning that you need to stage the files before committing. Do not forget that step. That is very, very important. Whenever a file is changed, you need to stage it before committing it. So let us look at staging and reviewing now. That is the next part of the workflow. So git add command makes any changes. Git treats any changed files as not in because that portion is not inside its repository. So you have to use the git add command to add those files for staging again. So let us say again, we'll go back to the internal structure. You have your working directory and then your index and staging. When you do a git add, your changed file is put into your staging structure now. And once you do the git add, let us say this is the output looks like when you do a git add hello world and then do a git status. See here, changes to be committed. It doesn't show the staging warning. It just says that files are ready to be committed. And if you want to unstage, use this command. So I'm just showing the workflow command by command and what are the outputs that will come and what are the important things in the output that you need to look at. I've just highlighted some of them, and I want you to look at those highlighted things when you are reviewing it. So we edited it and we added it. In other words, we staged it. Now we are going to commit it. That is the next step. So that's the highlight part. Just to remember, always stage changes, because people quite often try to commit a file without staging and say that my committing is not working. So you have to stage a file after you edit. Again, another repeat. So finally, for committing the changes, you use the git commit command and then you commit it. So we move the file from while you're editing, then you're adding, then when you do a git commit, it finally goes and sits inside your repository. This is how the flow looks like. As I said, the index and staging is a temporary directory where a file is being untracked to tracked state. Whenever there is an in-between stage, that is when the index and staging part comes in. Just as the name staging is, it is an in-between state, a go-between place between the 2 places, between work directory and repository. So how do I do a commit? When you do this command git commit, it will ask you to write a nice little comment about what is this commit is all about, so that when you want to review it in the future, you can come ahead and see it. So you write something like this: committing the latest changes to hello world.py, and files with hash will be empty and Git is very smart. Here you see here, if you are trying to be smart and try to give an empty comment, git will abort the commit. It will not commit it at all. You cannot escape in git without giving a comment. Every commit will have to have a comment. The comment can even be a space or a dot or something like that, but it cannot be empty. In other words, git is encouraging best practices, saying write something so that you will be able to review when something goes wrong and when you want to come back and look at it. So let us see a nice workflow of what is happening here. We just talked about different things. Let me try to explain it a little bit better. So you have an untracked stage or an unmodified state, or a file can be in any of these stages. When it is completely not tracked by Git, it is in the first category. And if it is tracked, then it is not modified, it will be in the unmodified state, because it already knows what is in the content. It has already taken it into its database and there are no changes to it, then it will be in the unmodified state. So if you make some changes and still not staged it, it is going to be in the modified state. So the next step is, as I said, always you need to stage it. So from modified, it will become staged. And once you commit it, so let us look at it a little bit better. So you now, from untracked stage, you add a file. When you're adding a file, then you need to go to stage situation. And after staging, you need to do a commit. So once you complete a commit, that file has become unmodified because there is no changes. All the changes that was in the file has been committed, and Git says that that file is not modified. So tomorrow you come and say that, oh, I missed this line, or I missed writing some feature. Then you start writing it, then you start modifying that file. Then what happens is, this activity, you are editing the file from unmodified state, it moves to the modified state. And you feel that, okay, you have completed your edit, then you want to commit it. So what you do is, then you do a staging. After your staging, then you go ahead and commit, and file becomes unmodified now. These are the different states of or workflow that happens in your GitHub repository. So these are the different states a file lives inside the Git world. And finally, if you want to delete a file which is already being tracked, let us say you want to remove a file, then that file enters a state of an untracked state. So this is how the entire flow looks like. This is the thing that we saw for the last 5 to 10 minutes. Git add, git status, git stage, git commit, and then delete or remove. So these are the different things. Let us move ahead. So it's a short summary of the different commands that you use for doing the workflow. For editing, you use your Vim or Emacs or Nano or whichever one that you are familiar with. Then for staging the file, that you use the git add command. To review your changes or what is happening or what are the files that has changed, you use the git status command. And for finally for committing, it's the same word that you use, git commit. Git branching and merging strategies. This is the backbone or the heart and brain of Git's power is coming in. The parallel development and merging your parallel development. That is what branching and merging is. Let us look at what is this are. So git branch command, what it does. We already saw what is a parallel development, where you're developing your super secret iPhone 8 features. Then you do a git branch of your command. Git branch is your command and create your feature. So let us say this is your main line. When I say main line, all the production or master development happens here, and you are here at the stage, and you create or initiate the command which says branch. So what happens is Git creates a copy of the same code and allows you to work on that code. But branches are technically lightweight movable pointers. It is not exactly a complete copy of all the files. Git internally knows that exactly at what point of the directory that you initiated the commit. It knows which commit, that is, it has a key, alphanumeric key, and it has a pointer to that key. You don't end up with multiple copies in your home directory or whichever working directory if you go there. But Git manages beautifully and hiding the complexity from you. It knows exactly the key and then it just manages the keys alone. Even if you navigate to your Git directory and files, you will not be able to find exactly all the files there. You will be finding only hash map keys there. So think of branches as lightweight movable pointers. It is movable because when you do a merge, what happens is this branch just starts pointing to the master itself. The branch stops existing. It is no longer the branch is available unless you go to any of the commit hash keys and say, I want this particular commit that is residing here. Pull that commit, then you can get it. Otherwise, the branch doesn't exist. It is just a movable pointer. So let us talk more about the pointers here. Let us say you started your version control repository with a snapshot A. When I say snapshot, it is a copy of your code that you have saved to Git. And we are at commit 0. When I say C0, think of it as commit 0. I'm here, and then you made some changes, and the previous changes are pointing to commit 0, and Git names it as C1. So your snapshot is like that, and you have gone all the way to C3 now. And this is the latest development happening place. And Git, whenever you're at the latest edge of the development server or where the latest development is happening, Git calls it as master. And master is just a keyword. You can have whatever name you want. It is completely flexible to reconfigure it. Remember, initially I showed you the configuration file. Those are some of the files so that you can use it for configuration, or you can custom configure it in each particular repository also. So, but generally people always use the word master for pointing it to the latest end of the commit. That is, latest commit will always be called master, and the latest commit will also have another pointer called head. The reason there is one more pointer here is this is the pointer that helps you to move yourself from one branch to another branch. Let us look at that little bit now. So now we are clear with master and head. Just think of it as two pointers pointing to the latest one, and master will always point to the latest one. Head, you can move it to anything. So let us say you are creating a new branch called testing, and you initiate a command called git branch testing. So what happens is this: Git creates one more pointer and points it to C3. So now you have created your branch, and this branch is existing, but your working and development always happens in the master because your head is pointing to master. So if you want to do some development in testing branch, so what you need to do is you need to execute another command called checkout. Before checkout, let us just say, when you say git branch, this tiny little star that you see here, there are two branches, master and testing, and the tiny little star of an asterisk that you see there, it shows that your head is pointing to your master here. So that is how you identify in which code branch that you are working, because Git doesn't have a separate directory or navigable structure. So you need to identify where you are in, where you are making changes. So Git branch, if you type in, it will list all the branches and put a nice little asterisk on the branch that you are currently pointing to. So now we need to move this asterisk to testing. So the command for that is something called checkout. So the activity that we are going to perform is switching branches. So when you do git branch testing or git checkout, this is what happens. I mean, you can do it in both ways. I am referring to another command, but anyway, this is the most recommended way, you can say, or this is the way that is more easier to understand. Git branch testing will move the star from master to your testing field. See here, now the git, the head is come here now instead of in the top. Now it is pointing here now. So that is how you move your head here, and your testing and development will happen here. So let us say you make some commits in your branches now. Let me just move to the next screen after removing the animation. So let us say that you have done some development in your testing and you have made another commit. So now you have gone to commit number 4 now. So now let us say your testing is completed and your testing has to be merged with master now. So master also has to come here now, because your testing is completed, your defect is fixed, and you want to roll it to production. That is what we are going to do now. That is called a merging strategy. Let's just go ahead and see that. So we are going to roll out a new feature or roll out a defect fix, and for doing that we need to push our code to the main line or master line. So the command for that is git merge, and what you do is you jump or move your asterisk or your working directory to your master. That is, when you do a git checkout master, it gives an option or output saying switch to master, and then those asterisks moves there, and then you say merge my master with my testing branch. You do a command like this, and it goes, and if it is straightforward, if those two files or the files within these two branches are discrete or not overlapping, it goes ahead and merges completely for you. There is no you don't have to do manually anything at all. Just type in git merge testing, and if there is no overlapping or two files are all unique and everything is pakka and clean, git manages completely for you and comes and says I have done it and everything is working fine. So in a logical way, this is how it looks like. Let us say your C0 up to C4 is in testing and your master is here in C6, and when you issue a command called git merge testing, fast forward testing, fast forward merging, this is what happens. It takes the changes from C4 and C6 and puts it into C7 and merges everything and moves the head here, because you do the merging from master, so the head will be pointed to the master. So this kind of merging is called fast forward merging. There are multiple strategies, as I said. This because it tries to merge everything here. You want to have the a software that is developed in C4 as well as C6. Sometimes you don't want C4 or you don't want C6, that is commit 6, whatever code that was developed there in C6 is crap and you don't want that, then you need to have a different kind of merging strategy, correct? Because not always you want to have the latest feature. Some feature might be too advanced, or some feature might be introducing too many bugs, might not be ready for release, so you don't want to merge it into your master line and you want to skip it and jump to the next commit. So there are different merging strategies, and I have shown you fast forward merging, one of the most simplest and easiest ones. And we talked about very clean merging, where the files are unique and they are not having overlapping lines, or wherever there is easy merging is possible. We saw that. What happens when there is a complex merge, that is, the same file has been updated by multiple people and same line has been updated by everybody. Say, for example, one person says open port 22 for this server, and the next person, let us say port 80 now, the next person comes and says, no, 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 we are going to make the default port as 443. I don't want to make 80 as a default port. So that person also changes the web server to run on port 443 now. So these two people have two different changes, and Git doesn't know how to merge these two files. So what happens is it throws an error. It obviously should throw an error. So it will give you a nice little message like this: automatic merging failed, fix conflicts, and then commit the results. So it will give you a Unix way of finding out the differences. This is the Unix way of showing the differences. You have the head file, that is a head branch, and then the testing branch. And it will say in head branch, the line is this Python script prints the welcome message, whereas the same line in the testing branch looks like print welcome to Valaxy demo for Git. So there are two different lines in the same place. How do you want me to merge is the question Git is asking you. So then you go ahead and say, I need both the files, and then keep them both. Or you will say, no, 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 I don't want testing, I want only head, then merge it appropriately in that way. So you have different strategies and different commands. I've just given you a simple example so that you can understand how a merge conflict works. And it is not always as easy as the example that I showed you, because some files are huge and some files are having multiple commits, there will be multiple changes, and Git will try to give you most of the information. If there is a logical error, somebody has changed the logical sequence of a file and tried to commit it, Git will not be able to identify those changes. It will just say that there is a change, but whether it will break the functionality, Git will not show you all those things. Now, all these things, let us say it was happening locally in your laptop, in your own version control. Now you are trying to merge it with global workflows, that is distributed workflows. Like a lot of people are committing and a lot of people are doing a lot of activities, and you're trying to merge them. So these are three different commands that helps you to merge your workflows with everybody: git fetch, git pull, and git push. These are all little advanced commands that is available for you to do a distributed workflow or open source kind of developments. When I say Git, So when I say git remotes, what I'm talking about is, remember the git add origin that I initially was showing for doing syncing repositories. So git remote is another command which will allow you to add another repository to your local repository, meaning you're trying to point your local repository to a remote repository, so that you can send your code to the remote repository for merging, pulling, and all those things. This is little bit out of place, but the reason I added this slide is, when I say remote repository, we need an URL in the cloud so that we can, or URL, when I say URL, I'm referring to the remote repository where we need to push. So that is why I just put up this screenshot where you can go ahead and click on new repository, create one. I'll show you how to do this. This is very, very simple, straightforward. There is only two fields that you need to fill in. One of the field is the repository name, and preferably you have two options, public or private, and then choose a git license. That is very, very important, because whenever you're committing a code to the open source world, it is assumed that it is free, it is ready for reuse and redistribute. So you need to choose the appropriate license, because if you're going to have the latest feature in the market, you're going to create a product, you need to have an appropriate license so that your competitor or your beneficiary pays you the royalty. So create the repository, and once you create the repository, you get the URL for that. See here at the bottom of the screen, you have the URL, and Git shows you how to use the remote URL so that you can add it to your local repository. If you run these two commands, this remote URL will be linked with your local repository, and from your laptop, you can be able to send commands. You are not able to see the link? You are not able to see my screen? So the next step after having your creating a remote repository is adding the origin to your local repository. These are the commands when you run it, and then when you this is the user-friendly name that you give for your remote repository. This is custom friendly. Mostly people use origin, but you can go ahead and create your own Tom, Dick, and Harry name there. And when you type git remote, it will give you the name of the remote repositories it is linked to. So that is very simple. And when you want to push some code from your local to the remote, this is what you do. Git push -u, that is the remote repository name, and then the local branch name that you want to push to. So remember that you can push it from any branch. So you can say git -push u, and then you can say here testing or whatever branch that you have locally that has been linked to the remote. So anything is possible, flexible. You choose how you want to develop your code. So you do that, you get some output, and then you get this star. Nice. If you get this nice little star which says that new branch master equal to master, that means your local master and remote master both are happy because both of them have the same content. If one of them is having a different content and Git is having a problem of sending your code there, you will get a big nice error message saying no, I cannot master, something has changed, go and fix it, and then do a push. And of course, the color changes are all for readability, and it is all my inputs. Git doesn't show you all those colors, so you need to open your eyes wide and then find out what is the error. So assuming that in my repository I had a hello world file, and I come to my repository, remote repository, it will appear here, and then you can find it here. So when we are doing a demo, we can see this. So let's move ahead. Finally, if let us say you are working in the reverse direction, you have a cloud repository and you want to push it or you want to pull it locally, then you do git fetch. So you say git remote origin, you set up the URL, and then once you set up the URL, you do a git fetch origin. It downloads all the files. It is very, very similar to your clone command. If you remember earlier, we did a git clone. It also pulled the remote repository, but when you do a git clone, you are not linking your local and remote. But when you do a fetch, you have already linked your local and remote, and you are fetching only the code. That's the difference that you need to notice. So what is this? Git push or pull? Pull. Again, git pull is nothing but, as the equation says, fetch plus merge. It fetches the remote code, and if you have a local code, and it tries to merge it along with your local code. So if you want to be lazy and if you want to do both the operations and you know that absolutely it is going to work, go ahead and do that. But big repositories, almost certain that this is going to fail. But if you are certain that this is not much changes are there, then you can go ahead and do this. And remember guys, some of the times the source code version control repository runs in gigabytes, not in megabytes, not in kilobytes. It runs in gigabytes and not 1 or 2 gigabytes. It is a lot more than that. So when you're doing a merge pull for the, think of comparing files which are in gigabytes in size, I mean multiple files, that might be like 10,000 files, 20,000 files, and you need to search through all of them and merge them. It's going to be a nightmare when you're going to do a pull command for a very big repository or very big main branch. So that is what this pull command is for. So if any of you is confused of who in the what now, what did you say so far? So let us try to demystify something that has happened so far with some logical representation of what we spoke about. So let us say you have a local repository at the bottom, and there is another local repo somebody else having on other side of the world, and there is an internet in between, sitting between you guys, and there is two public repositories sitting in the internet. So this is the initial setup that we are going to assume now for our logical flow. So what happens is, from your Git, you are going to push to your remote repository. So all these ABC commits have gone to your public repository now. It is in the internet and it is a public repository. So what happens? Anybody finds it, they like it, they do a pull or a fetch. So let us say this person has done a fetch now, and that has through git command. So all the ABC commits have gone here, and he sends that commit, or he adds some more commits to that repository. He creates, or he or she adds some more commits saying DEF. So that file has been changed, either for good or bad. That repository has been changed. Now he sends it to some other repository now using the push command. So originally we started on the left, now we are on the right. Your code has been modified in the internet and it is circulating with an improved version of DEF, and you go and find it. Oh my god, somebody has taken my code and improved it and I like it. Let me take that code and let me merge it with mine now. So I'm going to run another git fetch command and I'm going to pull the DEF now. So I have the latest commits, and this is how the entire flow happens, from push to fetch and again push to fetch. It keeps on circulating in the internet, and eventually every repository will have the latest content, and you have the distributed workflow happening all around the world. So let's move forward. That is how a distributed workflow happens. And Git tagging, it's a very nice feature. It is very similar to the Amazon tagging. It doesn't have a functional value of its own, but it helps humans like us to understand what Git is thinking in the background, or what each commit is referring to. So that is what tagging is all about. A logical pointer to a commit, and then you can call it a release, you can call it version number, you can have call it happy commit, whatever you want to call it. So tag is a command. So let us say what is tagging now. So lightweight tags, there are heavyweight tags also, I don't know, but anyway, let us see lightweight tags now. So when you issue a command, say git tag version 01, and your repository looks like this, you have 4 commits, and your master is pointed to C commit 3, and your head is also pointed to 3, or head is pointed to master. And when you issue this command, so what happens is this: another pointer is added to the commit 3. That is all is happening right now. There is nothing else happens. Git doesn't recognize tags apart from a pointer. So let us say you do another commit, your version point 1.0 still points to commit 3 only. So anybody in the world trying to pull a command, let us say you have communicated to your partner saying, take my code which is version 1.0, this is the tag for that, and pull the code with tagging of version 1.0. So whenever your partner or client goes to do a git fetch or a git pull for version 1.0, they will always be downloading the code which was up to this point. They will not be getting C4 at all, because the tag points here and the tag doesn't move unless you move it. So that is how tagging is useful. You make a feature releases or product releases and tie those product release numbers to a particular commit, and whoever is trying to take that feature, and if it is publicly available, they will always be pointing to that commit only. So annotated tags, Remember, we talked about lightweight tags. Now we are talking about annotated tags, meaning we are just going to add more junk or garbage into the Git repository, or making, in other words, adding more human readable information into the repository. So now you do something like git tag -a and then add this message also. This is release version 1.4. So when you do that, you have another additional pointer to the same commit, and you have the additional metadata information also. But these are all, as I said, for human readable information. Just to, if you want people to read what is the release document for version 1.4, you can add that information, very short description here, and put it there. And always Git will maintain those versions, and you can list all those versions to see how much your project has matured, whether you have made 10 releases in the last 1 year or 1 releases. So based on these things, people evaluate open source projects, and based on that, people commit on those projects or not. Say for example, Docker until 2014 was relatively new technology, but the way they were releasing features and products and moving from one version to another version was amazing, and a lot of people started believing in that project and investing in that project. They quickly went from beta version to prod in about 6 months, and Amazon, Microsoft, everybody got committed by Docker, and they started rolling out support for Docker right away when they went into production version. So feature tags might look like a simple feature, doesn't have any functional value from point of Git, but it has another business values or marketing values also. So use tags whenever it is necessary or whenever you want to use them. Finally, a Git log, just like any other log, it shows you what is happening in your repository, what are all the commits, what are the commits done by whom and what, all those information. Just like any other log is, you have a lot of options, lot of command parameters or substitutes available, so that you can find a particular log after a particular date or a particular repository, particular branch, particular person. All those filters are possible. Git supports a lot of regular expressions also within its command line, so it is completely flexible if you are familiar with the command line. So not going to spend much time here. Git log, and almost everything, as I said in the beginning, almost everything gets stored in Git. You have your source control, you can have your Git itself, Git configuration, Git management itself can go into Git, and you can have your build tools, configuration scripts, and everything into Git. And you can have your testing code. Let us say you're writing one-liners, let us say you're writing end-to-end testing cases or MQ scripts or financial reports, anything. It can go into your Git repository that can be version controlled and managed. So just remember that almost everything can be stored in Git. Finally, what I do is I install the happy package, and I'm always happy after that, because I know that Git is going to solve most of my configuration problems. I'm not going to run tar and rsync command anymore. So I will just have to code, and Git will take care of my merging problems.